Hey students, it's me, Mr. Fitz. So I just wanted to take us through a little bit of coordinate geometry and kind of the basics. So what is coordinate geometry? Well, you're probably all familiar with this coordinate plane. It's also known as the Cartesian plane. It was named after this guy, Descartes. He got credit for inventing it, not sure. Um, but anyway, what it is, it's just a mathematical model for allow us to kind of like plot points and use like a two-dimensional grid um, for modeling situations, whether that be functions or shapes or any sort of types of things, anything in like a two-dimensional space. There are three-dimensional coordinate planes too, but I'll let your future math teachers tell you all about that. Like there would be like a z-axis like coming out of the paper. We're just going to focus on two dimensions. So what are the two dimensions? Well, we have the x-axis and the y-axis. So if we wanted to plot points, what are we going to do? Well, the x-axis, if we think of it as like a number line, these would be the negative numbers and the positive numbers. We just kind of plot our x coordinates and our y coordinates. So let's take a look at some examples. So first of all, this would be a set of coordinates. It would be a number for our x and a number for our y. And for example, we have 0, 0. That's here where the x coordinate is 0 and the y coordinate is 0. That's also known as the origin. I got a lot of questions about that. And so if we're starting here at the origin, we wanted to go up in a positive direction on our y, we'd go that way, or negative that way. So for, also got to talk about our quadrants. So the x's and y's are all positive in this first quadrant here. That's the Roman numeral 1. Here's the Roman numeral 2. This is the second quadrant, and the x's are negative and the y's are positive. Third quadrant, they're all negative. And the fourth quadrant, we have positive and negative. So you definitely want to write this stuff down on your notes. Make sure you remember this stuff. So let's look at some points. So for example, like if I wanted to plot the point 5, 2, I would go 1, 2, 3, 4, 5 in the x direction, and then up 2 in the y direction. The point negative 2, 3, well, it'll be negative 2 in the x direction, and then up 3 in the y direction. And same here, negative 5, negative 1, negative 5, negative 1. And then over here, we have this point 2, negative 7. So it would be positive 2, down 7. So that's just plotting points. You're going to see some examples of some problems like that. Just a little practice. So that's a refresher for us, hopefully. So let's look at some other things. So for example, if we wanted to plot, say, or graph lines. So we're not going to do a lot of like, later on in the year, we'll get to like graphing circles on the coordinate plane. But right now we're going to focus mainly on just linear equations. So we're not going to have to worry about any parabolas, any quadratics, or anything like that right now. So here's our linear equation that we're probably familiar with. This is slope-intercept form. Y equals mx plus b. M is our slope, and b is our y-intercept. So let's look at an example. So let's say our slope is negative 3, and our y-intercept is 5. Well, what is the y-intercept? The y-intercept is just where, if you want to think of it as intersect, it's where the line is going to intersect the y-axis. And that point here is going to be 0, 5. That's our y-intercept. And so if I wanted to write this as a linear equation, it would be y equals negative 3x plus 5. And then there's our y-intercept. And that's the coordinate 0, 5. So the x is 0, and then I'll go up 1, 2, 3, 4, 5. Okay. Now we're going to talk about slope, and I rewrote this slope here to negative 3 as negative 3 over 1, and here's why. Hopefully you remember that slope is our change in y over our change in x, and we're going to talk a lot about slope. You're going to see this in many more videos to come. And so we're going to think about like this is the rise over the run. I like to just think of change in x, change in y over a given change in x. So how much is the y changing for any given change in x? So if we think about here, like if our x is changing by 1, how much is our y going to change by that? So if I'm going to use slope, what I can do is just go, all right, well, down 3, that's my change in my y. So I'm going to go down 1, 2, 3. And then I'm going to go over to the right in the positive direction. So down 3, which is my negative 3, over 1. positive direction for the x. So that's my change in y over my change in x. And I can do the same here for here and here, and I get this point. You could also go in the other direction, right? You could think about this. You could rewrite this as positive 3 over negative 1. That would work. And you could go up 3, 1, 2, 3, and then to the left 1. And you bring that point over here. Here's another little trick you can use. Use a table. So we talk about this in class a lot. So if you just plot some points, so for any given x, so 0, I just picked some easy numbers, 0, 1, and 2. If you plug those numbers in, what is your y going to equal? So this is a function. Our input, say, is 0 for our x. Well, negative 3 times 0, because this is 3 times x. Negative 3 times 0 is just 0, so my y would be 5. And there's that coordinate right there. If I plug in 1, well, negative 3 times 1 is negative 3. Negative 3 plus 5 is 2. So that's my point there, 1, 2. I could do one more. I could say, like, if I plug in 2, well, negative 3 times 2 is negative 6, plus 5 is negative 1. So that gives me the point 2, negative 1, and then you can just graph it. Use a straight edge or a ruler and just or graph your line right there. So that's graphing lines. Okay, let's try something else. Oh, we're going to see standard form now. You've probably seen this a little bit in algebra. Standard form is written as ax plus by equals c. This is also a line. It's a linear equation. The y is raised to a power of 1, so it's not a quadratic or cubic or anything like that. So for example, 6x plus 4y equals 8. Let me think about that. Well, I want to get this into y equals mx plus b form. So I need to do a little bit of algebra here. So first thing I'm going to do is subtract 6x from both sides. And that's going to leave me with 4y equals negative 6x plus 8. All right, and then I want to divide both sides by 4. And that leaves me with y equals negative 6 over 4x plus 2. All right, well, I want this in the simplest form possible. You can, for most part, like you can see, negative 6 over 4 is fine. But if it asks you to simplify that, I need to simplify this slope to negative 3 over 2 times x plus 2. So that's my slope, that's my y-intercept. I'm going to show you one quick thing here. Let's see if I can bring up my calculator. Yeah. So what was that? It was negative 6 over 2, negative 6 over 4, right? So if I just plug that into my graphing calculator, right? Negative 6. Oops, hold on. I want negative 6. I want to hit this negative button. 6 divided by 4. Enter. And that gives me negative 1.5. But I want to simplify that. I want that as a fraction. So I can hit math. And then it's the first thing here. Enter. And look, it simplifies my fraction for me. You can also use the alpha y equals tool to plug in a fraction. And you can do negative 6 over 4. Enter. And then that simplifies it for you too. You see that? Negative 3 over 2. Bingo. Pretty cool. All right. Where were we? Oh, so sometimes you're going to have to find slope. Just want to do a little brief review of slope. So we have, this is a horizontal line. Our slope is 0. So if you imagine if you're like skateboarding, snowboarding or something, or skiing, you're not going to go anywhere on a horizontal slope unless you power yourself, of course. Then we have vertical slopes. Those are undefined. Again, you don't want to skateboard or ski something like that. That would be undefined. And then we have positive slopes and negative slopes. So remember, slope is change in y over change in x. One thing to remember here, and I would note this, is that the change in y for a horizontal slope is going to be 0. Because 0 divided by anything is 0. So if this part is 0, then the whole thing is 0. If the slope is undefined, the change in x is 0. So that means this is 0. So think about that. Like if you have a vertical line, your x isn't changing. Your x is your horizontal distance. There is no change in that. So, and then same here for a horizontal line, there's no vertical change. So your y is equal 0 here. Your change in y is 0. So that's just a little thing I wanted to point out there. Um, so here's an example of finding the slope of a line passing through the points 8, 6, and 5, 1. Hopefully I can finish this video under 10 minutes, I'm not sure. So 8, 6, and 5, 1, here are our points. You can just plot it, right? Plot it on some graph paper, or if you want to use a graphing calculator, you can do that too. And then think about your change in X and your change in Y. So if I just plot it here and then just count the vertical distance here, my change in Y is 5, and my change in X is 3. That's, by the way, that triangle is the symbol for change. I should have said that earlier, but that's what these are, triangles, and they represent change in Y and change in X. So that's triangle Y, triangle X, that means change in Y over change in X. So it's 5 over 3. There's my slope. Another way you could do it is you could just stack your coordinates and then think about like moving along the number line. If you're here, change in X, that's my triangle X. If I'm at 5 on the number line, I have to go up 3 to get to 8. If I'm at 1, I have to go up 5 to get to 6. Now you're probably wondering, what if I stack them the other way? Well, yeah, then it would be -3 and -5. But -5 over -3 is the same as 5 over 3. It's 5/3. So that's an improper fraction. Please leave them as improper fractions. I don't know why we have to call them improper. I think they're great. So just leave it as 5/3. You don't have to use a mixed number. Yeah. So anyway, that's all I have for today. I hope that helps. And please, please, please let me know if you have any questions. Thank you. Thank you so much for watching. Bye. Some kind of coordinate geometry stuff. So the coordinate geometry is really just a model, and it's built based on, I'm going to start over. I got to take one of these out. Test, 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 test. Actually, basically it's just a model used in mathematics for like modeling. Anyway, okay. 3, 2, 1, action.